Hi everyone, so I'm just continuing the video on applications of calculus to kinematics, and we're going to have a look at the last two parts of this question. These last two parts are going to use a lot of the information that we found in previous sections. So we need to, in this part, calculate the average speed that the particle, speed of the particle in the first 5 seconds, and then calculate the average velocity of the particle in the first 5 seconds. So the thing is that to calculate speed, we just need to find the total distance that it's traveled and divide it by the time, because speed is distance over time. So what I'm going to do is I'm going to actually draw a bit of a diagram, okay? So I've got E set up down here. Now, essentially what I'm going to be doing here is drawing a parabola, but I'm going to be drawing it in one dimension. So the thing is that the equation for the displacement was given by a parabola, and so, yeah, we're going to see how we can do that in one dimension. Now, I might just get rid of that end of the line there. So, the thing was, we have some kind of origin point, we'll call it 0, okay? Now, we know that initially the particle was, what distance? 16 meters to the left of the origin. And so I'm going to mark that on the graph. So negative 16 there. Now, we also found the turning point because we had the velocity equal to 0. And that is where the, interesting. But that is where the graph actually turns around. We saw that it had a velocity of 0, so it's like slowed down, it's come to a stop, and then it's accelerated going the other way. And we found out that that was 25 meters to the left of the origin, as we can see right here. So that's the maximum distance that it goes from the origin, 25 meters away in the negative direction. So it started here, and it's gone over this way, and it's reached this point, and then it's kind of gone, all right, we need to like head back now. So it's coming back this way here. I don't know how far it's going to go back, but we need to find what the displacement is at the end of that 5-second period. So when t equals 5, x is given by 5 squared minus 6 times 5 minus 16. I think that's right, yep. So x is 25 minus 30 and then minus 16. Now 25 minus 30 is just negative 5, then take away 16 will be negative 21. So it reaches this point here, which is negative 21 meters. Obviously this is not to scale, okay? So in calculating the speed of this, it's traveled from negative 16 across to negative 25 meters, and then it's traveled from negative 25 back to negative 21. So all up, well, it's traveled 9 going in the negative direction, and then it's traveled 4 back. So in total, the distance traveled is going to be 13 meters. And we know that the time is just 5 seconds, because we're told in the question that it's for that 5-second interval, the first 5 seconds. So all that I do now is I go speed equals distance over time, which in this case is 13 over 5, which is 2.6. Oh, wasn't expecting it to do that. Well, anyway, 2.6 meters per second. So that is the speed. Now, the velocity, on the other hand, for part F, and the question again this time says calculate the average velocity. So essentially what I want to know is what the velocity is for me to go on from negative 16 to negative 21, because that's been the overall change. It's had some velocity going negative, and it's gone more negative, so there's more of a negative focus there, but then it's come back and it's being countered by this positive part here, where the velocity is going to be a positive number. So the average velocity is going to be I would assume a smaller number than 2.6, and also that it's going to be negative because it's still actually overall moving to the left. It's going from negative 16 to negative 21. So the thing is, to do the average velocity, I'll call it V just with an average or AV thing down the bottom there, is really just the change in displacement over the change in time. So I can say x2 minus x1, that's the change in displacement, divided by t2 minus t1, the change in time. And so the displacement initially was negative 16. Well, actually, I might use the later point. So the displacement at the end was negative 21 minus, and then negative 16 was the initial displacement, divided by t2, which was after 5 seconds, minus the initial time, which was 0 seconds. So that ends up leaving us with negative 21 plus 16, which is actually just negative 5, divided by 5, which happens to be negative 1 meters per second. So overall, the velocity is sort of just looking, in this case, from the start to the end point. It's that's the overall change, but it's not considering the fact that it's gone way out and then sort of come back to that point again. But yeah, that's the difference between speed and velocity, as we can see in that last part. So to consider the speed, it had to be going significantly faster to go out and then travel back to the point, whereas the velocity is just looking at the overall change and considering those differences there. So the thing is that we can calculate average velocity using this rule here. Okay. In the same way, we can calculate average acceleration. So if questions come up about that, then that would be the change in velocity divided by the change in time. So that would be another one which may need to be used. But these rules are, I would say less commonly used. More likely that you'd be expected to find, say, an instantaneous velocity or instantaneous acceleration, something like that. Now, obviously in these videos, I've only used the differentiation process as well. I haven't used the anti-differentiation. However, given your understanding at the moment of differentiation, how it works, it's really going to be very similar questions, just that you might need to start off with, say, an acceleration and make your way back to velocity or something like that. But anyway, that's all I'll say on that. So I think that should do it for this video, and I will see you all next time.